widow algorithm by Maximovshin and its implementation. It's a home assessment 1. A quick intro to the black widow optimization algorithm. It's a genetic algorithm which adds a new stage to the basic generation algorithm, and it's a cannibalism stage where after procreation a pair of agents, one of the agents, the weaker agent, is deleted, and also the weakest part of children is deleted. I implemented it as a class. You simply put initial parameters when you create an instance of this class. It's a function that you want to optimize and some parameters, and then you run optimize function and get the result. Here are some main parts of code, such as a mutation stage, where I simply change a pair of bits in each agent that I want to mutate. By bits I mean elements of vector of data of agent. And here's the reproduction stage, which includes also a cannibalism stage. I decided not to create a special class for agents because I implemented agents as an NumPy arrays, which allowed me to then implement functions that I optimize with NumPy parts of code, and it worked with better performance than simple Python classes. I had an opportunity to create wrappers over NumPy classes, for example, NumPy array or NumPy number, but I thought that it would be an overhead, so I stopped on simple NumPy arrays. I implemented example functions from the original paper. I took 5 of them and also implemented some other functions just to check that all works right. Here are results of optimizing these functions. One could run example.py script to generate them again. And I also optimized a real-world problem. There is a paper where author tries to optimize an electricity adapter. The main idea is to maintain the same level of electricity on different parts of a system, even when some parts of system requires more or less energy, and the fitness function in this case is a difference of electricity levels on different parts of the system. There was a problem. I needed some data about the system to iterate through it to calculate the integral, but I did not have it. So I made a function that simulates this data. I ran it before the run of optimizer, and here are the results of optimization of this function. It works quite well, and here is the comparison between electricity controller with BWO algorithm and with basic controller. Few words about the code. There's no plagiarism. I coded it by myself, and I also created and implemented the ideas and architecture by myself, and I also used neural networks to support me in this project. It helped me to write docstrings, comments, sometimes helped me to debug some problems, and realize the PID controller part, because it was quite hard to understand how it works. And some examples of the code, here it is. I can run tests and they will pass, and I can run example py, which runs optimization of all example functions, and it also works right. This is the end. Thank you.